Right, the aim of this lesson then is to look into, in quite a bit of depth, what you're going to be expected to do in the analysis stage of your project. Okay, so the objectives of this session are to gain an understanding of the key characteristics that need to be demonstrated in a good project analysis. Secondly, hopefully from doing this activity you will gain ideas and inspiration for how you could go about completing the analysis for your project idea. Okay, so they're the two key aims for today's session. Okay, how are we going to do this then? We're going to do it by looking at some actual examples of past projects that have been moderated and marked officially by AQA. You're going to look at the analysis stage for these three projects. So we've got an endless runner game, project 2, a snakes and ladders project, and project 3, a takeaway ordering system. Okay, you'll be able to access these three PDF files and read the analysis for each one and hopefully come to a decision as to how good you think these particular projects are in terms of a mark, and also being able to justify that mark. Okay, so yeah, that's the key aim for today. Now, to do that, we just need to go back to the start point here, because you remember the year 2 project mirrors the development life cycle, and if you remember, the breakdown of the project marks is visible on screen, and you can see that the total mark you could score for the analysis stage in the project, the first stage of a project, is 9. So we're going to look now at how you would go about achieving those 9 marks and what characterizes a really good analysis. Okay, you're then going to try and apply that understanding to the 3 projects to see if you can identify which is the best, which is the worst, and so on. Okay, and then we'll have a look at the answers later this week. So the analysis then, so key things that you're looking for in the analysis. Now this is the advice that is actually given to teachers who have to mark the projects. So the first thing we're looking for is a detailed description of the problem or the investigation that's going to be the focus of the project. Okay, there needs to be clear evidence that research has been performed, and you're going to hear me talk a lot about this word dialogue. Okay, so the depth of the research and how that informs the project is really important, and we'll talk about that in a second. One of the key things you might say for the analysis, the end goal of the analysis is to have those client requirements or that set of objectives that will then become, I guess, the foundation of your project, and the design, the implementation, the testing will be all based, and the evaluation ultimately will all be based on reflecting on the success of achieving those requirements. So the requirements are a key part of the analysis and form part of the mark scheme. Okay, the last thing that you'll see in analysis is evidence of modelling the proposed solution, so the actual system that's intended to be introduced. And in the analysis stage, because it's still very early days, there just needs to be evidence of modelling that the assessor feels will then be useful later on in design, that design can build upon. Okay, key questions that you should be asking yourself when you're reading these projects and once you've read through the analysis is, do you actually understand what the project is about and what the project is going to do, and do you feel that the objectives that the students have written are detailed enough and specific enough? Okay, so this is the marking grid that teachers use to actually come up and finalise a mark for the project, and you can see the 4 points that I've just mentioned are really kind of hidden away in these descriptors. Okay, so you can see descriptor 3 is a level 3 descriptor, and if you're in this level you've done very well, and you're maybe going to score between 7 and 9 marks. Okay, key things here that you can see. So the problem is sufficiently well modelled to be of use in subsequent stages, so we've touched on that. You can see that the requirements have been arrived at through dialogue, and that's involved intended users of the system or recipients and has been an outcome of the actual investigation. So you can clearly see how the research and the investigation and the involvement of the users has led to the formulation of those objectives. They've not just been plucked out of thin air. So that's a key thing, showing that story about where the requirements have come from. At the top, we've got fully documented, requirements have been fully documented in a set of measurable and appropriate specific objectives, i.e. they're SMART. And the key thing is that they cover all the areas of functionality that the investigation, the research suggests is required. Okay, and the final thing at the top is that it's fully scoped. Well, if you've done the 3 previous points, then it's likely to be fully scoped, and it's been presented and written in a way that a third party could understand. So someone who's has no knowledge, previous knowledge of the project, could read through the analysis and understand what the project was about, what the requirements are, etc. Okay, you can see as you drop down through the levels how the wording changes slightly. So this, if we look here in level 2, most but not all requirements documented, and so on. Okay, if we look down again at level 1, requirements partly documented, not all of which are measurable or appropriate. So you can see how the wording just changes slightly, and then it obviously affects the judgment and also then where you place that student in terms of their mark. Okay, so those 4 key areas then, just talk about them a little more. So the investigation, the dialogue. So what we're looking for here is once we've got the clear problem statement and description written, is the research that's been done. Okay, so that dialogue could involve interviews with the client. It could involve the use of questionnaires and gaining feedback from the users who are going to be using the system. It could be an observation that you've conducted yourself, actually going and watching the system that's currently being used and writing down in detail how it works and operates, and really showing in depth that you understand the processes involved, which are then going to need to be replicated by your computer system. So an observation could be a technique that you might see or use in your project. You might analyze the existing paper-based documents used in that system, particularly if you're making a digitalized version of that system. Those paper-based documents could be really useful in terms of providing you with the data that your system will need to be captured, the format for that data, etc. So analysis of the existing paper documents. Okay, it might be that you want to analyze they have an existing computer system that you're improving, and therefore there might be a detailed analysis of that particular computer system, how it works, the software that's being used, and the problems with that existing computer system. Okay, the last area where you might see some in-depth research, and quite a common one perhaps, maybe more for people making the games, would be looking at similar systems or similar games that already exist, and taking inspiration and ideas and suggestions for how they could be improved even, that then feed into your ultimate project and your requirements. Okay, so there's a range of different investigation, and when you see these investigation techniques being used, that is part of showing this dialogue, which is really important to showing where the requirements have come from. Okay, so if I read through an analysis, I should be able to see evidence from responses in interviews and the research that shows me where requirement X has come from, where requirement Z has come from, and so on. So you should be able to work back from the client requirements and see where the research has actually identified the need for that requirement. And the clearer that relationship is, the better the project is. Okay. Now the quality of the dialogue also matters, okay, and this is a nice little example just to kind of pinpoint that. So if you look at question number 1 here, do you like games? 95% said yes. So maybe in this case the student has polled some prospective users of their system, and from the viewpoint of AQA, that's not a particularly good question, because how does it actually help you derive and identify requirements? Well, yeah, 95% said yes. So what? How's that going to be helpful to me actually understanding what this system needs to do? You can see that the question underneath that, what kind of towers would you like in a game, is a better question, because you're allowing your users to be able to give you information that might actually help you identify the requirements for the end product. Okay, and then you can see Again, another good example down at the bottom here about questions that a quiz might ask, and again asking the client or the user in this case as to what specifically what examples of the types of questions are that might be used, and thus helping you identify what those question types should be for your actual quiz. Okay, so that relationship is really, really important, like the dialogue and the depth of that research and showing it. One final example of that is here, and you can see this project, a very technical project here. Not quite sure about the specific details of this one, but you can see an example of what I mean in terms of we've got some research that's been done. He's clearly in this first line kind of acknowledging the fact he's consulted with the users and members of the organization for whom he's making this system, and we can see that he's taking that into account and explaining how it's going to be then incorporated, their opinion is going to be incorporated into their into this project and the ultimate requirements for this system. Okay, so again, we can see where the requirements are coming from when we look back on this research. Okay, so once you've had a look at the problem statement and the research and that dialogue, okay, which is all about demonstrating where the requirements have come from, you then obviously get to the objectives themselves. Okay, you've already got the experience of looking at objectives, so the key things here are that they are specific, they're smart basically, they've got the characteristics of SMART, and that we can see how they've been arrived at as well. Okay, they're not just plucked out of thin air. Okay, I've picked out that wording from the MARC scheme again, which you can read through, but you can make a judgment on that and make a decision depending on how well you feel those requirements have been written. Okay, but I think that one is a bit more straightforward to do there. Okay, so here's just some general advice again about requirements and what you should feel after having read them, particularly in terms of, in theory you should be able to just jump to the objectives of a particular analysis, read through the objectives and get an understanding as to what the solution should do. If you can't, then it suggests that they've not been very well written. Okay, the last thing you're looking for in the analysis stage is modelling. I'm not going to worry so much about this at this point, but modelling, if you're doing a database, might include examples of the actual data that's going to be held in those tables, and data tables are similar to what we did recently in the MIDI projects. It might involve the use of different flowcharts to visualise and represent the proposed system and how data moves around it, and make, using diagrams that are hopefully simpler and easier to understand and visualise. For databases, we might see the fact that we've got a multi-table database there, again suggesting complexity. We might even see the use of prototyping as well to help actually understand and elicit the requirements for the project, maybe more suitable for games, or we might see sketches if we're making a game of how the game's actually going to operate and work and the different options that would occur during the game. Okay, the last final example we've got down here is in a physics-y simulation project where we've got examples of modelling of the actual equations that the computer application will need to mirror when it's produced, the simulator's actually produced. Okay, so not so important at this stage, but something just to be aware of. And is the actual modelling useful? Could it be useful to you later on down the line is the question that you want to be asking yourself when you see the examples of that. Okay, last part of the analysis, and this is a key part, and you're going to see this when we go through the answers later this week. One of the judgments that the moderator will come to with a project, and they'll base it mainly on the objectives, which should be challenging, is that if they don't feel that they're up to A-level standard, then the actual project can be marked down quite substantially. Okay, so the next question is, well, how do you actually know whether a project is complex enough to be A-level standard? Well, just on these two slides, and you can pause the video here and have a look through these. Okay, but you've got examples of some project titles and a brief outline of the project as well, and you can then see the potential algorithms that could be used. Okay, in this case from Group A, which is those high-level skills, and that gives you confidence that this could be an A-level project. Okay. If, however, you read through the analysis and you're seeing objectives that look quite simple and could be implemented using simpler algorithms and maybe fit the descriptions on the right hand side here, then maybe you're looking at a project that is not of A-level standard. Okay, so that is your key task. Please make sure you read through the analysis carefully and complete the Microsoft form at the end.